So you fill the concrete with the V funnel, and you remove the bottom gate and measure the time, how much time it took to, so it should be 8 to 12 seconds. That's what you measure here in V funnel. Next is passing ability test using L box test. There are two boxes, one is vertical box and one is horizontal box. You measure the passing ability, you fill the vertical box with the SCC and then lift the gate, and it has to pass through the vertical reinforcement gate that is placed at the center of the vertical and horizontal box. It has to flow through the reinforcement, and you measure various things like time taken to reach 200 mm, time taken to reach 400 mm, and also the height difference H1 by H2, which gives the blocking ratio. So you fill the vertical box, lift the gate, and then it has to pass through the reinforcement. There is a indication at 200 mm and 400 mm. You measure the times also, and also you measure the height difference between both the ends, H1 and H2. H2 by H1 we call it as a blocking ratio, the height differences, and it should be more than or equal to 0.8. What does that mean? The height difference, it should be generally, it should be flat. Otherwise, the difference should be less. If it is less than 0.8, what does that mean? It is taking more time, or if the mix is stiff, cannot reach the other end. So many things, and or otherwise there is a blocking at the gate while passing through the reinforcement. So you're filling the vertical box, and there you're lifting the gate, and then you're measuring both ends, that end and this end. So the height difference H2 by H1 will give you the blocking ratio. It should be more than 0.8. That's what. Next is U-box test. U-box test also, there is a U-box. So you have two channels, okay, two chambers, I can say, two limbs. And then one of the chamber, you fill it with concrete, and again, similar to L-box gate, you place the gate and you lift the gate. It has to pass through the reinforcement, and it has to come to the other end of the U-box. The height difference between the first limb and second limb should be less than 30 mm. That means 3 centimeters. These are the U-box dimensions. You can see one of the chamber is filling. You can see the concrete is raising. Concrete has come up to this. You can, by cursor, you can see, and then it slowly. So it has come up to this. Once it is completely poured in the one side of the box, you will lift the middle gate, and then it comes to the other limb. So you will measure the height difference, this side and this side. This should be less than 3 centimeters or 30 mm. That is what you do. And then there is a simple other test which is called Jaring test. Jaring test is a combination of, you have a ring, and then inside the ring you place the Abraham's cone, and then you pour the concrete into Abraham's cone. You lift the Abraham's cone, and then the concrete flows through the Jaring. And then what you measure is the height difference between outside and inside ring. Okay, it should be less than 10 mm. That means it should flow freely even after passing through reinforcement. So here also you measure the passing ability. So you have a Jaring, and then you place the slump cone, fill the slump cone with self-compacting concrete, lift the cone, and then it has to pass through Jaring. And you measure the inside height of the concrete and outside height. This should be less than 10 mm. There is also fill box test. Initially, when we started, like in 2001, we actually fabricated one fill box and did the experiments. So here also there is a complex structure. If we have the fill box replicates of 20 mm dia, and then you pour the concrete of one side, and it has to flow to the other end. you measure the filling area. The filling area should be 90 to 100%. There should not be any gap. That means it has to completely fill. So you can see here the experiment. So basically you're flowing, it is filling, almost 95% it is filling. What happens if your mix is not good, it gets blocked at top and then other end it will come out, okay? So this is what you measure, what we call filling, the filling ability. That means the complete. And last one I'm going to explain, this is called screen stability. This is a very simple test. You take 10 liters of concrete, keep it in a bucket, keep it for 15 minutes. You take the top 5 liters of the concrete, and then this top 5 liters, you pour it in a 4.75 mmC, and you sieve it. After 2 minutes, what you do, when you sieve it, what will happen through 4.75 mmC? Only the mortar comes out, passes through the 4.75 mm. You have the aggregate on the your sieve. So you weigh the mortar sample. The percentage of mortar to the original concrete gives you the screen stability. What does that mean? If it is a good concrete, when you keep it for 15 minutes, the aggregate should remain there. That means on the top layer. If it is not good concrete, what will happen? All the coarse aggregate will settle down at the bottom of the bucket. So when you pick the top 5 liters, what will happen? You have more of the mortar. So it should not be. So when you measure, the segregation resistance recommended values are between 5 to 15%. It should be like less than 5% if it is having more excess resistance. More than 15%, more segregation. That's what you do the test. When you sum up all these tests, like slum flow, 600 to 800, the limits are like this: T50, 2 to 5 seconds, J-ring, 10 mm less than, V-funnel, 3 to 12 seconds, V-funnel, T 5 minutes, plus 3 seconds, L-box, blocking ratio, 0.8 to 1, U-box, high difference, less than 30 mm, fill box, it should fill 90 to 100%, GTM screen stability test, it is between 5 to 15%. And how do can you do all the tests? So acceptance, what is the acceptance for SCC? You can do at least 3 combination of tests. Combinations, Japanese, what they do, slum flow, V-funnel, U-box. Sweden, they do slum flow and L-box. J-ring and U-box, Europeans do. And slum flow, either U-box or L-box, and V-funnel 5 minutes. This we found better, based on our experiments. I'll quickly run through because I have another 15-20 minutes time, 15 minutes. Maybe I'll quickly run through. A lot of things are there I wanted to share. When you look into the applications, this is the first application of SCC, 1998. This is Osaka gas station in Japan. You've seen the first slides, the congested reinforcement. SCC is poured into this particular application. You can see the inside portion of the Osaka gas station in Japan. This is Akashi Kaiko Strait Bridge. This opened in 1998. It connects 2 islands of Japan. As part of my research work, I happened to visit Japan in 2009 for one of the world's largest earthquake tests on shake table. So this is one of the pier of the one side of the island, you can see. So here they poured 240,000 cubic meter of SCC, completely SCC. These are my pictures when I visited there, because in 2009 visited, I made a point to visit this place, and I visited along with my Japanese and US friends. This is the Akashi Kaiko Strait Bridge. Delhi Metro Railway applications, the initial applications, the large scale applications in India, Delhi Metro Railway Corporation, and tunnel linings in DMRC. Tunnel lining, this is one of the applications in tunnel lining in Sweden, and even DMRC LW, SCC. And in Netherlands, some of the precast concrete elements, very interesting application. So concrete is poured, and once it gets cured, these are lifted. You can shift it to some other place. These are precast concrete elements made using the self-compacting concrete. This is one of the site in Italy. Almost 29,000 cubic meters of concrete volume is poured. You can see no one is there. Just concrete. SCC is poured through boom concrete placer, and then SCC is getting poured. No one is vibrating, and no one is there. You can see the other picture. You can see. This is very interesting applications in Spain by Ravindra Getu from IIT Chennai. When he was in University of D. Catalina, Spain, he has made some precast ventures. Some of the applications. And I tried one. At the end, I'll tell you one of my BTech project, one of my students' BTech project experience. Coming to the mixed design, I'll just give you a small glimpse quickly. I'll run through. So the two methods I'm explaining. One is the method which we were developed, and this is the method by Japanese. This is suggested by Okamura et al. In 1993. This is the first method that came from University of Tokyo, Japan. So in this method, you have to fix coarse and fine aggregates initially. By achieving or adjusting water powder ratio and superplasticizer dosage, you get the self-compactability. Limitation, first is the maximum of 50% to total sand to aggregate volume. You limit the coarse aggregate. And then remaining out of coarse aggregate, again, 40% is your coarse, out of aggregate, 40 is coarse and 60 is your mortar. Again, out of 60, you divide sand and paste accordingly. Okay, 40 is your sand and 60 is your paste out of mortar. So what you do in this method, you decide the air content. It depends like 2%, 1%. And then you fix the coarse aggregate 50 to 6%, 60%. You measure the coarse aggregate bulk density and the dry rotted density. This is how we measure the dry rotted density of the coarse aggregate. Place it in 3 layers, 25 strokes each layer. That is the dry rotted packed density of the coarse aggregate. That you take it for the calculations. So suppose if you take 1,000 liters of concrete, assume 2% is your air, 20 liters you remove, 980 liters you are designing. Bulk 50% if you are assuming it as a coarse aggregate, 50% of 980 is 490 liters. And then if you multiply with bulk density, you get the mass. And then you can again calculate the absolute volume. And fine aggregate, using the small V funnel, you actually get the fine aggregate content. So this is the small V funnel. We do the trials, mortar trials, to get the required mortar quantity. So volume of mortar is, if it is 284, then you deduct from 980 and then 40% fine aggregate. So basically the method goes like this. I'm not giving too much importance here because this is completely the mixed design part of it. So flow test, using flow test, you measure the water powder ratio. How much, water to powder ratio it should be. So based on that, you decide the water powder ratio. Based on the V funnel and flow cone test, you decide the mortar. And then superplasticizer is added, and then you do the regular slump flow, whatever test for concrete. I'm not giving much of because it's a detailed explanation of the mixed design. I've just given a glimpse of Japanese method. So now I'll take up one more. How do you do the SCC? SCC making using the fly ash as the cementitious method. We know that we have a large fly ash is being generated due to our thermal power plants, and the fly ash particles are spherical in nature and then smoothy, glassy surface, and it gives the ball bearing effect. The excess calcium hydroxide, if you impart fly ash, it will create more calcium silicate hydrate, which will add the strength to the concretes. And unless like silica fume or metacavalin, you can add it in larger amounts because heat of hydration won't be there, up to 150 to 350. That's why we call it as ideal powder in SCC. So my method, like normal mix design, once you do, you achieve a workability of 75 to 100 normal concrete. After that, because we have a more coarse aggregate in normal concrete, you replace the coarse aggregate using fly ash in various percentages, 5, 10, 15, and slowly you achieve the self-compacting concrete. That means we have a more coarse aggregate. Replacing coarse aggregate with fly ash or any other cementitious material will give you flow to the concrete. At the same time, you have to conduct other tests like V-funnel, L-box, and other things. And VMA will actually guard against segregation in the event of, because we usually observe there is a change in water content due to aggregate moisture and other problems, and even the grading problems. So for our experiments in 2001, we have taken OPC, and then we have taken Raichur thermal power station fly ash collected from Raichur, and 12 aggregates and natural river sand. That time, natural river sand, now all the sites they're using crushed rock fines or other alternatives to natural river sand. We have used PCA based superplasticizer and a VM. So these are the mixes you can see here. So for 30, 160 or fly ash, and then fine and coarse aggregate values. Coarse aggregate is less when compared with the fine aggregate, you can see here. These are the slum flow V funnel and L box. Here you can see 7, 8, 9, 10. We have taken it for the final mixes. Here you can see V funnel is satisfying, L box is satisfying, GTM screen ratio is satisfying. Very interesting study, why fly ash. We have actually measured 270-day strength also. That means after 6 months. After 9 months, we measured, when we check the fly ash contribution to the 28 days to 270 days strength. You can see here for a replacement of 37% of fly ash, you can see the normal concrete to the 270 days normal concrete. There is an increase in 90 MPa. You can see here. What is that? 90 MPa. If 55 is your 28 days, 90 MPa is 270 days. That's the contribution, long-term contribution of fly ash, long-term strength concrete. So very interesting point here to note is when you're pouring, when you make the mix, when you're pouring, you should not vibrate. Even if you're doing trials at your college, when you're pouring the concrete, you just have to pour. You need not vibrate because it is SCC. Hardened properties, yes, it is almost gives the equal properties to the normal concrete. Very interesting, IS 516, they've added new tests other than the strength tests. 2018 IS 516. What are those? Water penetration tests, and then initial surface absorption test, very important test, and RCPT tests. These are the three very, very important tests when you are making SCC. SCC usually you make it for tall structures and other applications, particularly high strength applications also. When you are making these three tests are mandatory, this mandate is given by IS 16700 2017 criteria for structural safety of tall concrete buildings. When you are making concrete for these buildings, you have to have the concrete which rapid chloride RCPT value, it should not be more than 1000 coulomb, superstructure not more than 1500, water penetration test maximum 15 mm for foundation, 20 mm for superstructure, and shrinkage strain value and water other values are given in this particular code. Here I would like to show some of the values. See here, as per ASTM, if you see, more than 4000 is high chloride permeability, and it should be low chloride is 1000 to 2000. One of the site at test conducted by Stedman, one of the site at Amravati, tower, they calculated this RCPT test wherein it has got low. Some of the trials, these are only trials tested by Stedman. And coming to the cementitious materials, how much we have to add? This recent IS 1026 2019 gives you what is the percentage of cementitious materials. Earlier, there was no mention about adding the cementitious materials to the concrete. Fly ash can be up to 15 to 30, GGBS up to 25 to 50. Metakaolin, as I mentioned, you cannot add too much because it is very grind and fine powder. Both silica fume and metakaolin, you can add between 5 to 15% of by mass if you take the total cementitious materials. Yeah, coming to the almost end of my presentation, I would like to give you importance of volume fractions, particularly in self-compacting concrete. When we considered all of the world various mixes, okay, so these are the mixes at various places using different fillers. The interesting thing is volume fractions. Volume fraction is particularly paste, how much paste is required to maintain the flowability of the concrete and to maintain homogeneity in the concrete is very, very important. Paste is a combination of cement plus cementitious material plus water. We call it a paste. In normal concrete, the volume of paste is around 23 to 29%. But in case of SCC, you can see here 35 to 41%. More paste is required in case of SCC. So we have come to a conclusion, particularly for all over the world, the volume of paste is generally between 0.35 to 0.41 in case of other places. But when it comes to the Indian researchers, Indian cases, you can see the paste content is between 0.37 to 0.46. We need more paste because our grading or aggregates, or you don't get a graded aggregates if there is a change. So we require more paste due to various reasons. So that's what SCC mix requires nearly 40% of paste volume. But in case of Indian researchers, you can see it requires 0.4 and above, 40 and above. This is due to angular crust aggregates, or otherwise, if you wanted to avoid viscosity modifying admixture, you need to put more paste into the system. And these are some of the trials I'll show you with, that means not only fly ash alone, not only GGBS alone, you can make a blend, fly ash and metakaolin tertiary, these are the mixes with different blends. The top one is with fly ash only, and then the bottom one is metakaolin. And then the bottom last is fly ash and metakaolin. These are the slump flow L box V funnel values, and these are the strength values. You can easily achieve 50 to 60 easily. 50 MPa, 60 MPa. You can see 80 MPa, 120. You have to look, durability point of view for a pillar. And with the GGBS, this is Shobha Indraprastha building. I've taken it from our JSW friends, wherein so slump is around 650 to 650 plus or 30 mm, and composite strength is around 63. This is the site chart I just showed you. M25 grade. Normal cement OPC is 170 and GGB says 170. This is the 50 MPa we got for 96 days, 111 days. And this is a tertiary blend. We tried with GGBS, alco fines, and silica fume with 350 cement and rest of the other materials. We've conducted trials here. You can see compression test, V funnel, slump flow L box. These are the mixes, various mixes. L box, V funnel values, slump flow values. And we added fiber too, along with the other. So with and without fiber, you can see the values, compressive strength values. You can see the flexural strength values. There is a little improvement in flexure when you add the fiber for the SCC. And this is the split tensile strength values with and without fiber. This is workability results. Because workability reduces when you add the fiber. Fiber is the finest particle. It occupies, that means the surface area increases, so your slump reduces. This is the last one. I come to the last part. Quickly, I'll run through. We made a precast bamboo reinforced furniture element using SCC. We have collected the anthropometric data Based on anthropometric data, we finalized the bench, a park bench. We designed SEC for M25 grade. We used bamboo as reinforcement. We prepared the molds. We tied the bamboo, and then we casted the slabs, and then finally assembled and tested these benches. Marsh cone is a very important test to find out the optimum dosage of superplasticizer, particularly when you are going for the cementitious metal or any compatibility issues. The Marsh cone is a beautiful test to find out the optimum dosage. We found the optimum dosage of superplasticizer. And then we conducted all the slump flow, V box, L box, and V front. These are the values, all are within limits. And then accelerated curing test we have done because we cannot wait. Particularly BTech projects are 3 months, 4 months. When you start the work, you just have to find out next day. How do you measure the strength, projected 28 day strength using accelerated curing test? You know the procedure, right? Next day, the bottom plate of the mold you remove, and then these cubes with mold itself, you place it in curing tank. Sorry, you will boil it for 100 degrees centigrade for 3.5 hours, and then remove after after the boiling for 3 hours, and then 3.5 hours, and then remove the molds and cool it in water and then air dry. Then you test it. The strength this is the accelerated projected 28 day strength based on the accelerated curing strength. So this is the ergonomic data of the various people we have taken. Based on that, this is the sheen length, femur length and knee length. Based on that, we have taken the width of the bench and then height of the bench. Based on the 50th and 75th percentiles, we have decided the park bench dimensions based on the data. That's called it. Then bamboo is used as a reinforcement. Bamboo comes under grass, and then when you compare with the timber, it's have different properties. Like in timber, you have the radial fibers. Here you have fibers which are oriented in the axial direction. So you split it and then you treat because the reinforcement, as a reinforcement we have treated the bamboo. Then we have tied and made the reinforcement, placed in the mold and poured the SEC and made the bench. You can see the bench. And then did the deflection test for these benches. And it comes within the limits because if you take 4 people load 400 kgs, but we have gone up to 720 kgs. Over a period of time, deflection is minute till 4 mm. Okay. Anyway, that never happens. A percentage of cost comparison, yes, this is the 18% profit when it comes to the bamboo, the reinforcement, and normal concrete versus self-compact. Finally, coming to the end of my presentation, it's definitely a choice for complex structures, and SCC you have to arrive with any of the methods. But paste contents is very important. You're likely to have 38 to 45% paste content. Coarse and fine aggregate are either equal or sometimes coarse aggregate is lower, and all methods need guideline, laboratory tests, and field trials. Very important. You can't just go cast it in site. You just have to first do the laboratory trial, and then that's why generally for good structures, first they give the testing, and then based on the test results of the mix constraints, they design the mix, and then they do the trials, and then give it in the field. They conduct the field trial, and then finally the application. These are some of the references. Thank you. I think now the floor is open for questions.
Thank you, sir. Thank you. We will ask audience any questions is there. It was a wonderful presentation, detailed and a lot of testing procedures and about the SCC. And yes, sir has a detailed explanation he has given. I hope this will be useful for all the students who are looking for the opportunities. You can get an idea about what's happening in the industry. And he has given an elaborate presentation. A lot of people were requesting about your PPT, sir. They are asking the PPT whether it can be shared or not. I told I will take.
Maybe I'll see. I'll try to convert into PDF and later I'll share it. That's not a problem.
Okay.
I'll just read out some of the questions that are there in the chart.
Yeah,
Okay.
yeah. I will read.
Yeah.
What kind of a fiber added in SCC to
No,
get?
I'll do it from the top. I'll
Okay.
just read it.
Yeah. Please. Please.
No yeah. Maybe I'll come from the top because order of preference. What is the size of aggregate used in SCC?
Yes, sir.
So size of aggregate is usually 12 mm and then even 20 mm is used, not a problem. You can use 20 mm as long as the fresh property tests are satisfied. And if you can produce SCC, yes, the most common 12 and then 20 mm, 10 mm down, 12 mm down, and 20 mm. Usually practiced in at site.
And Sasi Kumar Arunachalam asked, next question I will read so that it will be fast. What about shrinkage and creep on SCC? Yes, asked Sasi Kumar Arunachalam.
Yeah, true. Here, when you compare the normal concrete, the shrinkage and creep values, a little bit more, but it is within limits because SCC having more powder content. Because you have your normal concrete, you have like 300 to 450 kgs, but here 450 to 600 kgs. When we tested it, when various researchers tested, shrinkage and creep are within the limits, and sometimes it is equal or sometimes slightly higher, but it is within the limits.
Okay. And other question is, I have answered. You can add some more things. Any special form or carried for SCC?
Usually, Maiwan shuttering, usually they place it because here the concrete is in a fluid state. Okay, so there should not be any leakage in the formwork, particularly when you place any normal shuttering. If there are leakages, it will be a problem. So usually, Maiwan shuttering is used most of the places, even for the Amravati construction and other places. Maiwan shuttering they use.
And And Arvind Kumar's question is, how much compaction required at the time of slab in case of SE? He joined intermediate of the presentation. I understand the question also.
Okay, so you don't actually do any kind of vibration for self-compacting concrete. That is self-compacting. So you won't vibrate. It compacts on its own. Okay, so.
Same question. One more question from Sasi Kumar. What kind of fiber added in SCC to get more strength?
Yeah, particularly for special applications wherein fiber reinforced concrete, if you are placing particularly for road works and other slab works where there is a problem, yeah, you can use any kind of fibers. Usually, steel fibers are used, and there are studies wherein we have tried with even the polyester fibers and other fibers also. The number of studies have been carried out. Particularly strength-wise, usually fibers will improve either flexure or tensile strength. When it comes to the compressive strength, a little bit, maybe 1 or 2% strength, maybe. Yeah.
And a lot of appreciations are there. I am leaving that we will have in vote of thanks. There was from Dibyendu Bhomik, which one would be suitable for SCC as cementitious material, hydraulic or pozzolanic type? Here, this is from Dibyendu Bhomik.
Yeah, pozzolanic is better because pozzolanic materials. What will happen anyway when you add water to the cement hydration happens. That excess lime remains there even after 1 year, 2 years. But when you add the cementitious material, what happens? This excess lime or Portlandite, whatever is present in the concrete, it will again react. That's what we call secondary reaction. It is always better to add pozzolanic materials. So fly ash is a pozzolanic material, and then GGBS. So you have to add depending on the availability also. So if you are in Ballari in Karnataka, you have a JSW plant. So using GGBS is wise choice. Suppose you are there in near to a thermal power station like Vijayawada. So Vijayawada thermal power station. So fly ash is abundant. So it depends on Vizag, again steel plant, GGBS. So you can use depending on the availability. Again, we are talking about green buildings and then embodied energy and all that. So to reduce the transportation of material, better to use the locally available cementitious material.
Yes, sir. There is one more question from Prashant Reddy. Which is the suitable plasticizer or super plasticizer for SCC? How can we decide about this? This is the question from Prashant
Yeah,
Reddy.
usually we use polycarboxylic ether based, PCE based admixture. We use it as a super plasticizer or a plasticizer.
Okay.
So to decide what is the optimum dosage of the super plasticizer, you have to do the Marsh cone test. Marsh cone test is a very simple test. You have a Marsh cone, a V funnel kind of thing, and then you prepare the mix, and then you add in different percentages of 1%, 2%, or say you start with 0.5, 0.8, 1, 1.2, 1.5, 1.8. And at a certain point of percentage, the flow will not increase. That means there will not be any change. That we call it as an optimum dosage.
Yes.
So Marsh cone test is the best one. And then polycarboxylic ether based plasticides are used for making
Prashant Reddy, I think your question is answered by sir. And next is from Ashutosh Sharan. He is from Alliance University, Bangalore. His question is why SCC is not used much in India when compared to the other countries. This may be a valid question.
Maybe awareness is not there, but we are using most of the sites in Bangalore, particularly for large complex structures. They're using SCC only, and we are good now. And the last 5-10 years, they're using SCC. But the only thing is, I have not showed most of the examples here because it's maybe I may have to show the new photos and other things. A lot of my students are working at various sites. They keep sending me the those photos and other things. SCC being used widely, even Bangalore Metro Rail Corporation they've used, and a lot of other places. It is being widely used in India nowadays.
Okay, sir. Thanks for your reply. And Baumix, another question: is there any specific type of viscosity modifying agent for a well mixed SCC?
Yeah, viscosity modifying admixture. Usually, what happens when you add viscosity modifying admixture? Suppose you are making SCC. You have an aggregate pile there. Suppose aggregate grading, if there is a change, suppose first batch you have a particular aggregate, and second batch again if you have a grading change. In the event of grading change, what will happen? This viscosity modifying admixture will take care about the stability of the mix. That's what we call it as when there is a modification or there is a problem with the stability in terms of viscosity. So this viscosity modifying admixture will take it. Even the water content change. Suppose sometimes the more water or less water, this viscosity modifying admixture will hold the mix intact. We actually add in a very small quantities. And there are a lot of people who supplies the viscosity modifying admixtures. I don't want to name the companies. There are a lot of other chemical. There are most of the admixture companies are producing viscosity modifying admixture. But as I mentioned, most of our Indian conditions, people don't use the viscosity modifying admixtures. They use more powder content instead of viscosity modifying admixture.
Thank you, sir. Thanks for your input. Can we get the early strength of SCC? Like if we want to get 16 MPa strength in the first 16 hours for 40 MPa mixed design? This is from Parth Patel.
Yeah, obviously, because when you go for, there are a lot of trials and people are achieving it. When you add silica fume and the mix you should maintain, that means you have to design the mix basically. So silica fume and then GGBS and then cement and then right ingredients and then right admixture and the right trials, definitely you can achieve. It's not a big issue nowadays because nowadays the farmer striking rate is very fast. Because they wanted to go to the next floor within 3 days.
Yes,
people are achieving it. Yes.
Can we Why are bubbles forming on self-compacting concrete upper surface? This is from Praveen GH. The
Yeah,
upper
it depends
surface.
on site. Yeah, it depends on site to site. And also, that's what you have to take care and you have to conduct all the tests properly at the laboratory, even at the site. See, most of the times, what will happen, laboratory condition, they do the trials when it comes to the site, they have to do one site trial. They don't do it suddenly if you pour whatever is there, because there is a lot of changes that happens when it comes from laboratory to the site, the material changes or the grading changes. You mean that's why you have to quickly conduct the site trials, and if there is any problem, you have to do the fine tuning of the mix. Very important. And the pouring again, sometimes why bubbles forming? Maybe the height of the pour. Usually, as I mentioned, like 1.5 meters is the free fall height of the concrete. So sometimes height is more. It depends. Like again, the compatibility between admixture and the cement or the cementitious materials also matters.
Yes, sir. That's
Yes.
it, sir. These are the questions, and nearly 150 plus participants attended, and they got benefited from this program on self-compacting concrete. Wholeheartedly, I wanted to thank you for your time and for your value sharing your knowledge. And I hope the participants gained a lot of knowledge from this particular program. And there is a one program next week we planned, that is our Sandeep Verma. He is expert in form work. He is doing a webinar. All the participants can attend and learn about the form work also. You can ask the questions related to the form work and the concrete. Both are the brothers kind of a thing. You can both are correlated. Wherever you go, concrete reinforcement and form work will come together. So everyone should attend. And thank you, sir. And I wanted
Okay. Yeah.
colleague to
Yeah. Thank
Germany.
you.
Yeah,
Thank you all the participants, and thank you CMTI for giving me this opportunity. And it is always pleasure to share the knowledge.
yeah. And I request my colleague
More you share, more you gain.
Janani, can you share your learnings from this program so that everyone will understand how
Yes,
you got benefited from that, and maybe the speaker will be very happy to know
yes,
about
sir.
it.
Yes, sir, definitely, sir. So, first of all, I'd like to thank Dr. Jagdish, sir, because this was a very detailed and informative presentation. We started off from the basics of the properties of concrete, the normal concrete, flowable concrete, and you went up to admixtures. What are the kinds of admixtures? What is the effect of admixtures on concrete? And you also said about the self-compacting concrete, and then their properties, the kind of tests we are supposed to do in self-compacting concrete, like slump flow test, V funnel test, L box, U box, J ring, fill box, and screen stability test. And also you covered a little bit of the mixed design concepts also. I thank you, sir, because this was a very informative presentation. I guess by seeing at the comments in the chat box also, people would agree with me. So thank you so